graph with a ton of questions with it. So I'm going to try to work this one out with. Okay, so I'm going to try to work it without referring to calculator, but of course, if you know how to type in this type of stuff in your calculator with change of base, you're going to have a little bit more of a check on the test. But all logarithmic graphs look like this. This is the parent function, whether it's base 4, base 10, base e, whatever. And then I know that this is going to shift him left 3. So I could take this point and go left 1, 2, 3. I could take this vertical asymptote and shift it left 1, 2, 3. So it would look like that. And then we've got this -1, just like all other algebra stuff, means it's going to shift it down 1 unit. So if I just try to eyeball all of these down 1 and connect them, this purple graph is roughly what I think the graph should look like. Now, I might need to go back and try to be a little more specific here in a moment, but this should be good enough for domain because I can see the x values approach -3 on the right and approach infinity, or on the left, and infinity on the right. The range goes down forever. It goes up slowly, but it does go up forever. So the range is everything. The vertical asymptote would be at x equals 3 for a normal logarithmic graph, but since we shifted it left 3, it's now at x equals -3. X equals because it's a vertical line. The graph's going up, which we call increasing. Read left to right just like you do a book. The point x equals 13 has a y value of what? Well, my graph doesn't help me with that, but that's okay because I've got the function. If I plug in 13 for x, this would be 16, and log base 4 of 16 would be 2, -1 would be 1. So it has to go all the way out. 13. You can see how quickly that graph flattens out. It does keep growing, it does keep going up, but just very slowly. X-intercept should be -1. Oh no. Okay, so that's it looks like it goes exactly through -1, so I was about to assume that. But when I shifted this graph down 1, I estimated this purple graph pretty heavily. So I don't know that that actually goes through -1. So all x-intercepts have a y value of 0. So we should plug 0 in for y and then solve this for x. And if it just happens to be -1, then great, but it doesn't look like it will be. So I could add the 1 over. To solve a logarithmic equation, you don't have to switch to left and the right side, but I think that if you put the logarithm on the left, you're more likely to remember that switching it from logarithmic form to exponential form is how you go about solving that. And then undo +3 with the -3. So it looks like when x is 1, y is 0. So that shows you how rough my graph was. It really should have been a little bit more like that. That down 1 drug that x-intercept way further to the right than I would have guessed. Okay, so that's a lot of parts. I went through all of them very quickly, but is there any part of that you need to ask more specifically?
How do you know if it's increasing again?
Increasing just means the y values are getting bigger from left to right. So the graph's going up, it's increasing. If the graph's going down, it's decreasing. So just think of the y values. Are the y values getting bigger or smaller?